This is my 10-minute video of me doing the presentation for the presentation. I am slightly ill, so just ignore that. Okay. Hello everyone, I'm Lila Johnston and I'm a sophomore at Scripps College majoring in environmental science. And I'm here to discuss the London smog of 1952 and its influence on environmental justice and present it as evidence for the Anthropocene. I will also be drawing important parallels to the Donora death fog incident of 1948. Environmental catastrophes have become more prevalent in modern times, but there was once an era when they were far less frequent. During this period, the presence of smoke in the air was often associated with progress and prosperity, while clear skies symbolized economic depression and unemployment. However, this mindset shifted at the onset of the Industrial Revolution, when the harmful effects of fossil fuels and the human exploitation of them began to claim human lives. In this presentation, I will argue that the London smog of 1952 prompted the crucial enactment of the Clean Air Act of 1956, serving as a catalyst for global initiatives in environmental justice and policy, while also providing evidence for the Anthropocene. First, I want to examine the earliest recorded deadly smog incident. This is known as the Donora death fog. This catastrophe occurred in Donora, Pennsylvania, and is widely recognized as one of the first human-caused environmental disasters. Understanding the importance of this event is key to supporting the argument. To grasp the significance of the Donora death fog, we must consider its context. It serves as a perfect illustration of the detrimental impacts of the Industrial Revolution and the widespread use of fossil fuel use during that era. In Donora's case, it was a small farming town, and in 1902, Carnegie Steel, an important industrialist figure, had established a large facility that was in the immediate vicinity of this small town. This factory had more than a dozen furnaces, all of which spewed harmful toxins into the atmosphere. And just 4 years later, in 1908, Donora claimed the area's highest volume of railroad freight traffic. Following all this traffic, a zinc works company commenced production. Due to the increasing development and the immense pollution it created, Pennsylvania skies were suffocated, and it caused the death of 20 civilians. By 1915 and by 1918, the death became so concerning that the American Steel and Wire Company settled its inaugural fine for air pollution-induced health damage. While an important step, it did not start any real change. It was just an example of large companies paying to keep their victims quiet. Real legislation at this point has not yet occurred. Let's examine what happened when fatalities increased. During the Industrial Revolution, Britain emerged as the workshop of the world, witnessing a significant surge in coal consumption from about 10 million tons annually in the 1800s to nearby 2 million tons by 1950. The 1948 Donora smog was notable, but it was nothing in comparison to the severity of the London smog of 1952. Lasting from December 5th to December 9th, 1952, this lethal fog brought London to a standstill, claiming thousands of lives and marking a pivotal moment in environmental history. Primarily caused by coal-burning domestic fireplaces, power stations, and furnaces, along with rampant industrial pollution, this smog revealed the profound impact of human activities on the environment. In the midst of the 1950s Industrial Revolution, coal consumption peaked, leading to a 24-hour burning in British homes, a drastic rise in CO2 emissions. Similarly to Donora, rampant industrialization in London resulted in widespread pollution. Thick, black smoke blanketed British homes in soot, darkening the sun and turning blue skies black. This environmental catastrophe highlighted the urgent need for awareness and action to mitigate the harmful effects of human activity on the environment. Before discussing the consequences of this fog, we must discuss why this deadly smog occurred. It has been stated that on December 5th in London, an eerie smog descended on the London community. While smog was always a problem in Britain, it became deadly due to an anticyclone hanging over the region on that day. This created what we now know today as an inversion effect. As we can observe from this diagram, this anticyclone pushed air downwards, warming it as it descended. This creates an inversion, where air close to the ground is cooler than the air above it, So when the warm smoke comes out of the chimney, it is trapped in the atmosphere where it would have normally just dispersed into the atmosphere. The inversion in 1952 trapped particles and gases emitted from factories, chimneys in the London area, compounded by pollution brought by winds from industrial regions on the continent. However, the situation worsened as the smoke darkened the sky, causing a dimming effect that further lowered London's already cold December temperatures. In response, civilians increased their cool usage to keep warm, exacerbating the smog. Unfortunately, at the time, few understood the consequences of these actions. During the 5 days, the effects of the practically poisonous smog were ghastly, leaving 4,000 civilians dead within 4 days, and upwards of 12,000 civilians dead after just 2 months. Death rates were also up by 2% the next summer. While a small amount of these deaths were caused by adverse effects of the fog, such as falling into the river or getting hit by a car due to the extremely low visibility, most fatalities are accredited to the poisonous smog. You can see that by this graph. Death rates increased from the 5th to the 9th. Following the Great Smog, a committee chaired by Sir Hugh Beaver, who was a British industrialist, was set up to identify the source of the smog. The committee made many recommendations. These recommendations formed the basis of the Clean Air Act of 1956. The act allowed local authorities to control emissions of smoke, grit, dust, and fumes from industrial premises and furnaces, and set up smoke control zones. In these control zones, emissions of any of these materials could be banned. Following the legislation, the age-specific death rates of men in the Greater London area fell by almost half, which is just some of the results this act had. The severe consequences of the London smog, including the tragic loss of 12,000 lives, prompted Parliament to enact the Clean Air Act 4 years later. This pivotal legislation serves as our primary source for evaluation. It offers valuable insights into the historical context and the actions taken to prevent similar disasters in the future. Now, let's delve into this document and discuss some critiques. This event took place in 1952, a time when technology was not as advanced as it is today. For instance, there were no air quality detectors. This limitation is evident of the language used in the primary source, such as the term dark smoke, as seen here. If Britain had access to modern-day technology, this legislation could have been based on precise data about air particles and emissions in different specific areas. Therefore, we understand that this document lacks crucial information. While it addresses the issue of dark smoke from chimneys, it fails to specifically tackle the broader problem of coal burning and its harmful effects prompted by industrial developments. The greater issue lies in fossil fuels. This oversight could have resulted in the establishment of different pollution zones and stricter laws for highly polluted areas sooner. However, despite its limitations, this document represents a significant step in the environmental justice. This catastrophic event spurred one of the first major environmental laws, and that is what we see now, the Clean Air Act of 1956. Why is this important? The Denora fog, particularly the London fog, leads me to the conclusion that significant environmental changes often stem from catastrophic events, resulting in loss of human life. However, these events don't always prompt immediate action. For instance, the US Congress didn't enact their first Clean Air Act until 1963. Although progress continued slowly afterward, culminating in President Nixon's establishing of the Environmental Protection Agency in 1970, the Denora death fog was years before any actual legislation was created. In contrast, London responded more promptly to the 1952 smog by passing the Clean Air Act in 1956, just 4 years after the event. This legislation marked a pivotal moment in environmental protection, as it regulated both domestic and industrial smoke emissions for the first time. Although significant strides were made, the transition to cleaner energy sources didn't occur overnight. It took nearly 3 decades and another Clean Air Act in 1968 to address the slow progress of local authorities in implementing smoke control programs that they had set in place in 1956. I now will present the argument in relation to the Anthropocene. In our class discussions, we've explored the concept of the Anthropocene. which suggests that human activities have significantly impacted the Earth's geological timeline, possibly creating a new epoch between 1945 and 1950. Both the Donora fog and the London smog serve as evidence of the onset of the Anthropocene. These tragic events caused environmental harm and affected nearby communities, coinciding with the early stages of the industrialization. Therefore, the evidence supports the idea of the Anthropocene era emerging around the 1950s, as proposed by McNeill and other authors when discussing the concept of the Great Acceleration. We can clearly observe this connection through the occurrences of these two devastating events. In conclusion, while the Clean Air Act of 1956 represented a monumental step forward in environmental protection, it was just the beginning of a long journey towards sustainable environmental controls. With this talk, I'll leave you with some questions. Could these events be used as evidence for the Anthropocene? Have these legislations prevented future disasters? And finally, do you think true change is only enacted when a large death toll occurs? Thank you.